So chapter 9, Regression Wisdom. So some issues and problems with regression. Subsets and curves. There are dangers of extrapolation. So remember, that's talking about the stuff that's like outside the data. Possible effects of outliers, high leverage, and influential points. And those things will be explained more later. Problems with regression. Of summary data. And mistakes of inferring causation. So then residuals. To determine whether a linear model is appropriate, we examine the residual plot. It is a good idea to look at both. A histogram of the residuals. And a scatter plot of the residuals versus the predicted values. If the histogram of the residuals has multiple modes, that may indicate that there are subgroups within the set of data. If a linear model is appropriate, the histogram should look approximately normal. And the scatter plot of the residuals should show scatter. That was a tongue twister. All right, so I'm going to draw two little plots here. So histogram of the residuals. And so this is going to be the residuals. Then this one is going to be the scatter plot of residuals. The residual is going to be over here. Predicted values down here. All right, so something like and then over here, X is going to be for higher than the linear model predicts. And the negative signs are going to be lower than the linear model predicts. And the dots are just going to be like on par with what they normally would be. If we see a curved relationship in the residual plot, the linear model is not appropriate. Histograms and other graphs of residuals can reveal subsets of data that will enhance our understanding of the original data. May lead us to analyzing the subsets separately, so at times we have some hard to see curves. So this is saying that sometimes the scatter plot looks straight enough. But a nonlinear relationship only comes to light after you look at the residual plot. So this first one is going to be the scatter plot, with the next one being a residual plot. So your scatter plot may look linear, but your residual plot something more like this, where it's got like a curve in it. So this type of residual plot shows the residuals versus the explanatory variable note the scale of the horizontal axis is exactly the same as that of the original scatter plot X and Y. When using a model to predict values of the response variable. 2 types of predictions can be made. And that can be interpolation or extrapolation. You'll be seeing a lot more of it this chapter. Last chapter was just like a here it exists kind of thing. So interpolation is making predictions within the given domain of X values, and extrapolation is the same thing but outside. That's only 2 of the 4, 6. Yeah, 6 pages. And we're done with 2 of them. We won't get through them all today. There's no way. But it should be perfect so that we'll finish them right before we have to leave tomorrow. So. Only interpolation is reliable. So extrapolation is unreliable because patterns can change abruptly. And so then some stuff about extrapolation. The farther our X value is from the mean of X, the less we trust our predicted value. Once we venture into new X territory, our predicted value is an extrapolation. Our extrapolations not reliable. I guess I should say our extrapolation is not. because we are operating, we are operating under the assumption that the relationship between X and Y has changed, even for those extreme values of X. And whatever you do, don't extrapolate into the future. Even if a linear model is appropriate, remember that association does not imply causation. There may be confounding variables that account for the association also, if we're plotting summary values like the mean, instead of individual values, the association may appear stronger than it really is. Another page down. I said another page down.
I didn't even see where it
We can pause. Joelle, is your hand surviving?
Yeah, that's alright.
My hand's getting tired. You got it, buddy. dad's at Buc-ee's right now.
Is he?
I'm so jealous.
I've never been there before.
Oh my gosh, it is amazing. Like, if you ever have the opportunity to go to one, 100% go.
It was all over my TikTok for a really long time. I'm like, go to Buc-ee's.
It's so good. They're like, big thing is the fact that their bathrooms are so clean, like, you could, like, eat off
Get
of
off
them.
the-
Like, I'm telling you, you go to the bathroom and you come out and there's somebody going in right behind you to clean it. Like, it's
Yeah.
pretty crazy.
I would hate for that to be my job, though, cleaning the bathroom. It probably will at some point, I don't know.
Yeah.
I mean, technically, it is my job right now because I clean my parents' office, and cleaning the bathroom is part of it. That's what I did on Sunday. So,
One isn't as bad as, like, 40, though.
it's true. It's true.
And they have, like, 120 gas pumps at every Buc-ee's. It's pretty crazy. They're building one in Tennessee near Miss Patton's daughter. That's where we go, like, all the time, so I'm excited. Because otherwise we don't really pass one unless we, like, intentionally go out of the way.
I'm excited for Cane's to be
Oh my goodness, yes. Have you? I'm guessing you've had it before.
Oh, yeah. Whenever we go to Ohio, that's always we always stop.
We get it in Louisiana all the time.
Yeah, I know
Kenny
they're
doesn't
building-
understand my fascination with it. Apparently they're building 2 of them.
Really?
One in Hampton and one in Yorktown.
Oh, yeah, I knew that.
And then there's one in Norfolk at ODU. So I go to that one every once in a while, but
And then they're also building a Chick-fil-A and another Wawa by my house. So excited. Chick-fil-A closer. I don't have to drive like 15 minutes.
right.
Well, more like 20.
It'll be so much more convenient.
You almost done with the red card? Need to get more cookie points. We only have one. College algebra.
Humble.
Sweet. They shake it out. What color do I want to use now?
Pink.
Pink? Okay, cool. All right, outliers, leverage, and influential points. When examining a scatter plot, it is important to look for any unusual points. There are 3 ways a point can be considered unusual. The first one is a point is unusual if it stands away from the others. This is called an outlier. That one's probably pretty self-explanatory. 2, a point is unusual if its x value is far from the mean of the x values. This is called high leverage. And 3, a point is unusual if, when omitted, so if we take it out, it significantly changes the linear model. This is called an influential point. This will change the slope of the line. And then just something else to note is that high leverage points can also be influential, but they don't need to be. All right, the 3 types of unusual points. The first is high leverage point, or points with small residuals. These points confirm the pattern, but are extreme values. The slope and intercept are mostly unaffected. But the R squared value will increase. Don't be misled that the model is now stronger. 2, it's outliers, not high leverage, not influential, and a large residual. This does not affect slope. But aren't consistent with the pattern. We're almost done for today, don't worry. It will change the intercept. Don't throw it away. The X value is near the center. Of the mean of the X values. And the last one, influential points, also high leverage, and probably small residual. These are the most troublesome. They aren't consistent with the model. And if the point is removed, the slope of the line dramatically changes. It changes the model. Don't throw it out without thinking. Alright, so we're going to stop there for today. We still have some stuff with lurking variables and some examples of, like, outlier, influential, high leverage, outlier, influential, low leverage, things like that, that we're going to go through and do, like, some graphs of what those look like. But I think we've done enough for today.